You are listening to episode number 56 of the Everything Ham Radio podcast. Today we're going to be talking about lightning protection. We're going to talk about some upcoming events and contests, as well as some hamfests for the next 2 weeks, and wrap it all up with some news from around the hobby. So stay tuned. Hey everybody, welcome back to the Everything Ham Radio podcast. My name is Curtis, my call sign is Kilo 5 Charlie Lima Mike, and I am your host for this podcast. This podcast is released every Thursday. You can follow us on Facebook at facebook.com/everythhingham on Twitter at K5CLM, on YouTube at youtube.com/everythinghamradio, and I'm not going to promise anything, but I'm going to try to get a little extra information in my YouTube episodes starting this episode. Eventually, I'm going to have like a face cam when I record this. So stay tuned to my YouTube feed for more information on that. Like I said, we're going to be talking about some lightning protection and what you should do to protect your station in the event of a lightning strike. Now, there's been a bunch of stuff that I've been told over my 20 years as a ham that, come to find out, is really not very accurate. And I got a really interesting story that happened to my father several years ago. But anyways, first off, I wanted to kind of talk to you a little bit, okay? This is actually the second time that I'm recording this podcast. And my wife's probably not going to be too happy with me because it's going to take a little bit more than the hours that I told her that it was going to take to record, because I bought a new program, and this new program is called Hindenburg Journalist, and I got it at an awesome price. I listened to a podcast called The School of Podcasting, and it just so happened that I was listening to the most recent episode yesterday while I was driving, and because yesterday was the World Radio Day, Hindenburg, the company that makes the program, had a special on for this program, and it was regularly $95, and it was on sale for $1.90. So I went ahead and bought it. Okay, I was gonna use it. I was gonna try it out. I tried it out. I actually got like 45 minutes or so into the episode, and it started pouring down rain. Now, my little recording studio is in a converted horse stall building, little horse barn building, and my recording studio is the tack room. Well, as you can probably guess, that the building is metal, so all of the rain that was just pouring down just sounded like it was the sound was deafening. I couldn't even hear myself talk when I was trying to record it. So I had to stop, and I spent like the next 45 minutes or so messing around inside my shop area, my woodworking shop area, and then finally decided to call it quits about 10 o'clock or so, about 11 o'clock, something like that. But anyways, was going to try and use that. I started using it, and as I was looking through some of the features on it, I realized that it doesn't have all the filters and stuff that I need in order to cut out some of the background noise and some of the other noise that comes along with recording sometimes, and didn't have all the other different types of things that I normally do in my post. So I'm going to have to put that on hold, and maybe next episode I'll record using it. I'll play around with it this week. So, but anyways, now I'm back to recording on Audacity like I have the last 56 episodes, which is an awesome program. Don't get me wrong. It's a free program, awesome program, but I really like the way that Hindenburg Journalist operates or works or whatever. But I'm going to have to download some plugins and stuff for it. But anyways, that's neither here nor there. So, before we go on, I got a person joined the group not too long ago, the Everything Ham Radio group, which you can find at facebook.com/groups/Everything Ham Radio. And he invited me to come to the Texoma Hamarama Hamfest in October in Ardmore, Oklahoma, for their 70th anniversary. And it's, like I said, it's not until October, so maybe I'll be there. I'm gonna try. I think it would be fun. But I'm gonna try and see if I can take off at least the 28th, which is a Saturday, and go up there for the day. We'll see if my wife lets me. You know how it is. Happy wife, happy life. And sometimes she doesn't like me traveling sometimes, or doing stuff without her, especially when it comes to spending money, which I would probably end up doing. But anyways, the guy's name was Sean that invited me to it. And I actually got an email a little bit later from a guy named Ed, and his call sign is W5CVE. And both of them are new listeners to the podcast, so shout out to Sean and to Ed. Thank you very much for listening to the podcast and for helping me spread word about my podcast. So, both of y'all, I'm going to try my hardest to make it to the Hamfest in October. We'll just have to see what life looks like for me a little bit later. My family is looking to adopt for the foster kids that we have in our care right now come July. So we'll see what happens. But anyways, I guess let's go ahead and start on our topic of today. Okay, so in the topic of today, like I said, it's lightning protection. Now, ham radio gear, as I'm sure each and every one of y'all are aware, can be pretty expensive. It can also be pretty cheap. But no matter how much the cost of the ham radio gear that you have, you want to make sure that you protect it, right? And one of those things is from power surges, whether that be a electrical power surge that comes over your AC line, or whether it is through lightning. And we're going to talk mainly about lightning today, but I'm sure part of this will also take care of the AC power spikes and stuff like that. But, you know, when lightning does happen, it can be a very dreadful thing. My dad, about probably 10 years ago or so now, he had, well, no, it was probably more than that, because I think it was right after I got out of college. So it would have been almost 20 years ago now. Whew, I'm old. I'm getting old. Anyways, he had a Pentium 1 computer. He had a Pentium 1, maybe Pentium 2 laptop. He had CRT monitors. He had a phone system, I guess. He had like 3 phones in his house that were probably older than I was. And a whole bunch of stuff. Ham radio gear. He had like a Kenwood 530, I think, or something like that. And a Linko dual band. And several other things. Well, one night, when a storm came through, his house got hit by lightning. And one of the neighbors saw it, ran up to the house and started banging on the door. Hey, is everybody okay? You know, lightning just struck your house. And he lost a lot of stuff. I mean, it came down to his tower and came in through his coax, got all his radios, got into the power, went through the power cord into the wall, and ended up taking out all his computers, his computer, my stepmother's computer, his telephones. It took them out, both their TVs, their stove, their dishwasher, their refrigerator, stereo, their AC unit, and I think my stepmother's sewing machine, I think. And you know, even if you don't have a good lightning protection system on your equipment, the one thing that you really should make sure that you have, whether you're a homeowner or whether you're a renter, is some kind of insurance on your stuff, right? Make sure your homeowner's insurance is paid up for sure. But you can also get it through the ARRL on your equipment and stuff. So make sure you get some kind of protection, so to speak, in insurance. But anyways, his insurance company actually went in and replaced everything, all of his equipment. And like I said, his computer was like a Pentium 1, and at the time, you couldn't buy anything less than like a Pentium 3. And he got flat screen monitors. He got new dual band radios. His HF radio that he had some kind of special filter or something on it, some kind of feature that was on the radio that was very rare. And the only radio on the market at the time cost like $1,800. So he spent like $350 for a used HF radio and ended up getting an $1,800 HF radio. Got all new telephones, new computers, new radios, new AC, new sewing machine, new flat screen TVs, all this stuff. I mean, he came out smelling like a rose. So whether you have actual lightning protection to protect your equipment, or whether you have insurance to protect it after the fact, make sure that you have something. But we're going to talk about the before the fact lightning protection in today's episode, okay? So whether you have just a Baofeng HT that costs what, $25 or $35, something like that, or whether you have, $3,000-$4,000 worth of equipment, you want to make sure that you protect your investment, right? So we're going to go in depth a little bit about what you need to do. Now, like I said, I've been a ham now for about 20 years or so. And one of the things that I've always been told is that, when a storm comes through, just unplug your equipment and unplug your coax and throw it out the window, or put it back through the wall, or however you have it coming into your house to hook to your radio, just throw it back outside. That will like air gap your system and protect it from lightning. Okay, I can see that. But, as storm spotters, if you spot from your house, you're going to need that radio. So you're going to have to keep the power on. You're going to need that antenna. So you're going to have to keep the coax hooked up. So if you are spotting from your home, if you are, say, net control for your Skywarn net, you're going to need that stuff. So you really can't unplug your antenna, your coax. The other thing is what happens if a storm comes through in the middle of the night while you're sleeping? If you're anything like me, it's going to take a tornado to wake me up. That's when I sleep the best. Whenever a storm comes through and it's raining on the roof and I'm listening to that, subconsciously because I'm asleep, I get the best sleep ever. And it takes a extremely loud clap of thunder or a tornado to wake me up in the middle of the night when it comes to rain. Now, you come tapping on my door, on my bedroom door, or knock on the front door, I'm like instantly awake. But so I don't really see that being a good method to protect your system. So if that's the only thing you got, then that's the only thing you got, and by all means do it. And you just have to go through the hassle of fishing it back into your house, right? So another thing that I've always been taught is you really only need one ground rod. An 8-foot ground rod, solid copper, 1/2-inch ground rod should be enough to protect your house, right? Or your equipment. And you put that next to your tower, you put it next to your house, whatever, and that's really all you need. Drive it into the ground and hook a wire to it and to your equipment, to your ground, to your tower, whatever, and that's really all you need. Well, all the information that I did, all the research and stuff that I did for this episode, really, I had this light bulb moment, and it's like, no, that's not all you need. Now, if that's all you can do, then it's better. Maybe it's better than nothing. If you live in an apartment or something like that, you can ground your system to a water pipe or something along those lines. At least it's better than nothing. So, all the information that I got from this came from the ARRL, and the majority of the information came from a 3-part series that was published in QST magazine back in June, July, and August of 2002. So if you have a QST magazine from 2002, I actually probably have them around here somewhere. I think I have every QST magazine I've ever had. But if you have it, you can look at it. And in the show notes of today's episode, you'll see what pages they're on. But if you don't fear. Just go to the show notes, and there's links to PDF version of each article. Easy peasy, right? And you can find the show notes of today's episode at everythinghamradio.com/podcast/56. That's the number 56. So go there, you can get the PDF, download them, and read the full information about them. So let's talk a little bit about the characteristics and what makes lightning. One of the things that I learned in this, that, I've been a Skywarn spotter now pretty much my entire ham career here, and I'm doing air quotes here. And I never really heard it explained the way that thunder is formed. I always knew that thunder came from lightning, but nobody ever really went into in-depth explanation of how it came about. So I really found this really neat. So, first off, you have to have some kind of storm, right? Well, you can have, random lightning events and stuff like that when there's no storm, but those are few and far between. So in order to make a storm, you have to have conditions that are necessary to form it. And typically that's a lot of moist air from the ground level to a few thousand feet, with cooler air above it and little to no wind. You also need plenty of sunshine to heat up the air mass near the ground. Now, when that warm, moist air is heated, it quickly rises up to heights where the temperature is below freezing, and eventually it forms a thundercloud, right? Within the thundercloud, there's constant collisions of ice particles that are driven by rising air and dropping air and stuff like that, and it builds up a static charge, right? So eventually, the static charge becomes significant enough where it causes an electrical breakdown of the air, thus forming a lightning strike. Now, when a lightning strike occurs, the return stroke rapidly deposits several large pulses of energy along the leader channel. The channel is heated by the energy to above 50,000 Fahrenheit. 50,000 degrees Fahrenheit. That is extremely hot. And all this occurs within a microsecond. So it really doesn't have time to expand while it's being heated. Therefore, it creates an extremely high pressure area. Now, this high-pressure channel rapidly expands into the surrounding air and compresses it. The disturbance of the air propagates outward in all directions. For the first 10 yards or so, it propagates as a shock wave, which is faster than the speed of sound, and after that as an ordinary sound wave. Thus, you hear thunder. That's how thunder is created. Isn't that cool? Nobody ever explained it that way. That to me is just really, really awesome. So, now that we know how it's formed and how thunder occurs, let's talk a little bit about us as hams. Now, we as hams, we always want to make sure that, we have our antennas up high, we have good propagation, we're above the trees or above the building or something like that. Well, yeah, that's great for propagation, but guess what else it does? That attracts Mother Nature to say, hey, here I am, come strike me with some lightning, right? So, while it may be good for long-distance communication, it's not very good for lightning protection. So, what you have to do is figure out some way to dissipate the energy if, by chance, you have a lightning strike. Now, I've had a 65-foot tower up in my yard for the last 11 years or so, and knock on wood, I've never had a lightning strike on my tower. I've been a ham now for 20 years. I've had, 20-foot push-up holes or so up until that point where I actually had a tower, and I never got struck by lightning. Again, knock on wood. So, if you're the lucky ones and you don't get struck, count your blessings, because, eventually it very well could happen. And not only with the height of your tower, the higher the tower, the better the probability that you're going to have a lightning strike. Not only that, but the area that you live in also increases your chance. Okay, if you live, say, in, if you live in Texas, you're going to have a higher chance of getting a lightning strike than, say, living in Phoenix or something like that, where there's not as many thunderstorms and not as many lightning strikes. So depending on where you live, depending on the height of your tower, all of that comes into play on your chances of getting struck by lightning. So there you go. So what is your chances? That's my question. So before we go on and we talk a little bit more about, we're going to talk about what needs to be protected, identifying that. But first off, we're going to take a quick break and hear a word from West Mountain Radio. So I really want to thank our sponsor, West Mountain Radio, for sponsoring this podcast. For those of you that don't know who they are, they make some awesome equipment. I've had the pleasure of using a rig blaster for about 15 years or so. They make several things other than rig blasters. They make the rig runner, which we've talked about in previous episodes, especially the one back in talking about mobile installations, I believe. And they also make a thing called a DC Go box, and that's what I want to talk to you about today. These things are awesome little boxes, okay? They're a hard plastic case that you can drop a battery into. And there's two of them especially that I want to tell you about. One of them has a Rig Runner 4008U mounted to the side of it. Now the 4008U has 40 amps of DC power coming in, and it spreads that out over 8 different slots. Each of them have their own fuse. Now, they also have one that has a Rig Blaster 4007U on it that also has 40 amps coming in, but it only has it across 7 slots. And again, each one of them are fused. The difference is, and you would think that the 4008 would be better, but I really think that the 4007U is awesome because it has a digital load meter, it has a USB charging port, it has a solid state push button on off switch and an automatic shut off for high and low voltages. So really awesome difference there. So if you don't need that 8th spot, definitely go for the 4007U. Now also on the side of these DC Go boxes that I'm talking to you about, they have what's called a Super Power Gate PG40. Now this thing is basically going to provide you an uninterruptible power supply. Okay, basically what this thing is a switch that tests to see if you lose AC power. Okay, so it has 3 plugs on it. One of them coming in from your power supply, one coming in from the battery that you have neatly tucked inside the case, and the other one going out to your Rig Runner. So in the event that you lose power, it will automatically switch over to the battery and you'll just keep chugging along like nothing happened. Now you might be in the dark, but at least your radios will be on. So awesome little system. There's these 2 boxes really for what you get have an awesome price to them. The one that comes with the 4008 is $249.95 and the 4007U is $269.95. Definitely go for the 4007U. It's only $20 more and you get so much more for it. Now, if either one of these are not exactly what you're looking for, you can customize your own box. You can even add a power supply to the back side of the box. So you have a all-in-one power system wherever you go. You can use this in your house. You can use this when you're camping. You can use it for your field day system. You know, all these different ways that you can use this DC Go box. So definitely make sure you go over and check it out. If you do, go to everythinghamradio.com/WMR and check out the free gift that you get. If you go there, you can get a USB power meter, I guess you could say, that will monitor your power outputage. You get it free with your purchase. All you got to do is enter the code at checkout. So make sure you go on over to the website, check it out, find something to buy there and buy it. I highly recommend West Mountain Radio for all of your power needs, really. Again, that address is everythinghamradio.com/WMR. Okay, so we're back. Let's talk a little bit more about lightning protection. Okay, first off, we need to identify what exactly you have in your station that you need to protect. Okay, so what I want you to do is I want you to get out a piece of paper. Okay, you got it? Make sure you get a pen too, because you're going to a pen or a pencil, something like that, because you're going to need to write this down. If you're driving in the car, don't do it now. Do it when you get home or wherever you're going to, or, well, actually, you're going to need to be in your station. So whenever you get back to your station, make sure you re-listen to this episode, okay? So you got your paper, you got your pen, okay? You need to look at your station and figure out what you have, what equipment that you have that you need to protect, Okay. And you need to draw a rectangle for every piece of equipment that you have, and do it by priority. Your $2,000 HF radio is probably going to be towards the top. Maybe your $25 Baofeng radio is going to be at the bottom. So figuring out by priority and start from the beginning. Okay, so let's say that your highest priority is your HF radio. So draw a little box on your paper and mark it with whatever HF radio that you have. Okay. From there, you need to figure out what comes off of your radio. You have a coax that comes off of it, and you have a power supply that comes off of it. Maybe you go to a keyer and you need to put that on there. Maybe you hook your HF radio to your computer. You need to draw a line for that. Okay. But first off, let's talk about the coax. If your coax goes directly out to your antenna from your radio, if you don't go through a power supply or a antenna tuner or anything like that, just draw a straight line out from that box out to the edge of the paper. Okay. If you go through an antenna tuner or an amp or something like that, draw into the box for each of one of those that you use and draw a line to them. Okay. And then eventually, wherever you go out to your antenna, draw a line to the edge of the paper. Now, on that line, on that coax line that goes out to your antenna, write what frequencies that antenna, that coax has. Okay, so if it's an HF radio and you have from, say, 10 to 80 meters that you talk on it on, write that down, 10 to 80 meters. Okay, on the other side of the line, you need to make sure and put the power usage that you use. If you use 100 watts, if you use 10 watts, if you use 4,000 watts, whatever, write that down next to the line. So once you got that on there, you need to look at where you get your power from. Is your radio AC powered or is it DC powered? Does it go to a battery? Does it go to a power supply? Does it go straightly to the wall? Figure out which one that is. If it goes straight to the wall, draw a line to the edge of the paper and put it to power. Put power, AC power. From there, figure out what else you have. Say you have a dual band radio, make sure you put that on there. And again, the antenna, draw a line to the edge of the paper, write what frequencies, write the power that you're going to have, and do this for everything that you have. All your radios, okay? On top of your radios, you need to talk about your computers, though, because if you do digital, you're going to be hooked to your computer. You're going to hook through a TNC, so you're going to have to put those on there. So if you have a TNC, put a box on there. Put what the TNC is. Put your computer on there, your monitors, your anything that connects to an outside source, you need to make sure and put on there. And put a line that connects each one of them. Okay. Once you have everything figured out, once you have all of your equipment, a box for each piece of your equipment, you have all your lines drawn, everything that goes out from your station, you have a line drawn to the edge, then you're basically pretty well done. Okay. But let's make sure that we actually are done. Okay. So let's take a closer look. And we're going to look at each block that you have. Okay. These are the questions that you need to answer for each block to make sure that you have all your connections done. So first off, the first question you need to ask, is there a connection between this rectangle and any other rectangle? Like I said before, on your HF radio, do you use an antenna tuner? Do you do a amplifier? Do you hook to your computer? Make sure that each connection that goes from that radio, from that rectangle, is connected to another rectangle representing another piece of equipment. Okay? Number 2, is there a connection between this rectangle and a device not yet included in this diagram? This could be like a standalone amplifier, power supply, computer, a TNC, modem, a network router, network hub, anything like this. If so, add that device now, draw the line to it, label it, and repeat this step until all your connections are made to any piece of equipment that you have. Okay? Number 3, is there any AC power connection required for this rectangle? Like I said, if you have, say, your radio uses AC power, your computer uses AC power, anything like that, the TNC, all that uses AC power. So, typically uses AC power. Sometimes your TNC will use DC power coming off your power supply. But anyways, if it uses AC power, make sure you have a line going from that block to the edge of the paper and mark it as AC power. Okay? Number 4, Is there any requirement to supply AC or DC power through a feed line to operate remote switches or electronics? Okay, so if you have, say, a rotor on top of your tower and you have a line going out, put that down. Make sure that you have a line going out to mark that, and it has to have DC power going through it. Say you have a weather station and it gets its power through the connection. You have a wired weather station. You have, say, a mesh network node. It's going to have power coming up through it. So it's going to have DC power on there. So make sure you put that on there as well. Okay? Number 5. Are there control lines leaving this rectangle going to remote electronics, relays, or rotors? There you go. There again. If you have a rotor, if you have some kind of remote antenna switch, anything like that. Okay. Number 6. Is there AC power leaving this rectangle going to your tower for safety lights, convenient outlets, crank-up motor, high-power rotors, etc.? Make sure you put that on there as well. Is there a connection to a telephone line, or maybe an ISDN telephone circuit, DSL telephone circuit, or cable, whether it's RF, video, or data to this rectangle? If you have a TV in your station and you use that with a dish network or a direct TV or something like that, or even an over-the-air antenna, you need to make sure to put that as well. Number 8. Is there a connection to another antenna system, such as a GPS, broadcaster, cable television, or DBS dish for this rectangle? We pretty much covered that in the last question. But, okay. So, number 9. Is there any connection to any other equipment elsewhere in the house or building? And by this, I'm talking about, say, you have a wired network in your house, and your antenna hub is somewhere other than in your ham shack. Or you have say, an intercom system. Those are few and far between now, but if you have a wired intercom system, do you have that? If you do, make sure you mark that down, okay? Now, not only do you need to make sure that you have everything that's connected in your ham station, but you also need to make sure that you have everything, any metallic item, within 4 feet in all directions from your radio equipment. You must be considered as part of your radio equipment, even if it is not electrically connected to it. Now, let me repeat that. Every metallic item within 4 feet of your radio equipment must be considered, okay? An example of this would be, say, a standalone telephone, on your other desk or something. Maybe you have another computer that sits on another desk or another part of the room. If it's within 4 feet of your ham station, you need to make sure and put this in your diagram. And the reason is because even if you are 4 feet away, or less than 4 feet away, if lightning comes in on the power cable, or comes in somehow gets into your system, it can jump that 4 foot. Lightning can jump that 4 foot and affect something else. So, if it's within 4 foot, it may not be air gapped enough. So you need to make sure that you include this in your diagram. Okay? So, now that you have your diagram drawn, here's what you do. You draw a line, draw a circle or a square around your equipment, around your rectangles. And on the inside of this rectangle, you're going to draw is all your blocks for all your equipment. On the outside of these is going to be all of the lines that go out to antennas, that go out to power, that go out to your rotor, to your mesh network, to wherever outside of your protected environment. Okay? So now that we got that, let's talk about how to protect each one of those lines that come in or go out of your station. Okay? First off, let's talk about coax. Coax is probably the easiest thing to protect yourself on. Okay? You can buy things that are called polyphasers, and you hook those in line with your coax. You have your coax coming into from your antenna, you hook to these polyphasers, and then you go out to your station. Okay? Now, every coax has to have one of these protectors. You can't just put it on one and that work. It won't work. Okay? So you have to have one for each of them. And no matter what type of coax it is, you need to have it. Whether it's, LMR 400, or whether it's a RG8, or whether it's a RG56 that comes in for your dish network. Each one of these has to have a coaxial protector on it, okay? We're going to talk a little bit more about word placement, stuff like that a little bit later on, but that's how you protect a coaxial cable. Another thing that is pretty common as far as antenna wires go is a ladder line or an open wire line. Now these are a little bit harder, actually a whole lot harder to protect, because you can't do it in series. You have to kind of do it, I guess maybe in parallel, I guess is what it would be. But you have to have two identical gas tube protectors to connect each leg of the feed line to go to ground near the entrance point. Now, each gas tube should be specified as capable of handling an instantaneous peak current of approximately 50,000 amps. Okay, that's 50,000 amps that these things have to be able to protect against, because that's about how much how much lightning does. It also has to have a turn-on voltage that will be well above the normal transmission line operating voltage. Okay. Keep in mind, though, the application of gas tubes to an open wire or a ladder line represents a shunt-type connection as opposed to the coaxial protectors, which are inline connections. This means that the transmission lines will share a significant amount of lightning energy with your equipment before the gas tubes begin to conduct. Unfortunately, this type of transmission line makes it difficult to achieve a high level of confidence in protecting high-performance receivers. Ladder lines are probably the best when it comes to SWRs and stuff like that, but they're really hard to protect. So, you have to answer that question yourself. If you're going to use ladder line, or you're going to use coaxial cable. Next thing, AC power. Okay, your AC power protectors. I'm not talking about the power strips that you buy at Walmart or Home Depot or Lowe's or Walgreens or some mom and pop shop. That's not what I'm talking about, because those things are not surge protectors. They're power strips. When they first came out, they were marketed as surge protectors, and they kind of do work. But basically what they are designed for is that the ground wire will handle the load of anything that comes in. Now that might be all fine and dandy when it comes to just a TV or something along those lines, but when you're talking about lightning, that won't work. It won't handle it. So you need something a little bit more oomph to it, right? You can buy a professional grade AC power protector, and basically this will provide a DC pass to ground, and it will protect it a whole lot better. There's a picture of a AC power protector in the show notes of today's episode. Each one of these different type of protectors will be in the show notes. There'll be a picture of them. Some of them actually have affiliate links that go to Amazon. So if you're looking to buy one, I know the polyphaser ones, I have a link to Amazon that you can buy some. So make sure you check that out if you are interested in buying some of these. Next up, telephones. Not all that common anymore. Landline phones, but some people still have them. If you do, you need to protect it. And by protecting it, I'm not saying, buy those power strips or those quote unquote surge protectors from a commercial retail shop that have the modular connectors on it. While it's super easy to connect a telephone cord to something like that, the electrical the juice basically that comes from a lightning strike will basically melt or totally destroy the connector by welding it or fusing it open. So if it's going to be a modular connector that you protect your telephone with, it's not going to work. It's definitely not going to work. Okay. You need one that has individual terminals for each line that comes in, not a plug. And there is a picture again on the show notes of today's episode. Control circuits are your next thing. This is things like a rotor control or a I don't even know what else right now. But basically, these are the same things. You don't want to have some type of plug to hook to this. Have the individual wires hooked to individual lugs that has the connectors. Okay. Ethernet cables are another thing. If you have a wired network, Ethernet cables, you need to have some kind of protectors. And there is some Ethernet protectors that you can buy, and they're basically like the telephone ones. Really, they have individual lugs on them. Some of them they'll have like a punch down block to put each individual wires going into them, and they're grounded basically similar to other protectors. Okay. You can buy the like the polyphasor type things for any kind of television coax. Like I said, it's like a RG56 type coax. You just have to make sure that the impedance for the unit is 75 ohms rather than 50, and it has an F-type connector rather than a PL259 or N-type or something like that. Another thing that you need to think about is your GPS. Why you would have a GPS on a stationary object, I don't know. But if you have a GPS antenna, you need to make sure that you protect that as well. And it basically does the same thing as like a telephone connector, okay? So, now that we've got that, let's talk about where you put all this stuff, okay? You need to have one area where you mount all these protectors, and that's called a single point ground, okay? Basically, this, for a medium-sized station, you can get away with like a 14 by 14 inch, 1/8 inch copper plate. You can do that. And you mount each one of these protectors onto that plate, and then you put a ground wire from that plate to the ground, or to your grounding system. We're going to talk about that a little bit later as well. Now, the single point ground, you need to figure out how you're going to lay it out, just like you did with all your system, with all your equipment and stuff, like we did before. So if you're going along with me and you're trying this out, get out or turn your piece of paper over, or get out another piece of paper, and you need to figure this out, okay? You don't have to do it now, but if you want to, you can. You already have it, you might as well figure it out, right? So you need to figure out how many wires you have coming in, how many coaxes, how many AC powers, how many Ethernet cables, all that. How many you have coming in. And you need to figure out which way the connectors go, because there is a input and an output side to these connectors, right? You don't want to have the input on top on one of them and the input on bottom on the other one, because you're going to mix up your protected area versus your non-protected area. So make sure that your protected area is one side of it and your unprotected is the other. Whether you do the top or the bottom or the side, the left or the right, it doesn't matter. Just make sure that all your protected sides that comes out from the protectors is on one side and all the unprotected is on the other. Now, something else that you need to figure out or think about when you're drawing this is gravity, okay? If you are drawing this up and down and your protected side is up, if you have a coax that comes up from a protector and then gravity pulls that coax back down to where it's touching or whether it's near a unprotected wire, you're going to have basically a spark gap between those, and it's not going to be protected anymore. So this is where neatness comes in, I guess you could say, or cable management. That's where that comes in. So anything that comes out of your protected or your protectors, get some zip ties and zip tie them to the bottom of your desk, or zip tie them all together or something. Just make sure that they're far enough away from your unprotected wires. Okay? So now that we've talked about that, let's talk about the grounding part a little bit. But I think we're actually going to take a quick break, and we're going to come back and talk about the actual grounding part of it. Okay, guys, just real quick, I wanted to interrupt a little bit. I meant to say this earlier before we got into our topic, but I needed to make sure that y'all heard it during the main portion of this, because I know some people don't listen past the main meat of the episode. So I wanted to make sure that Alan Meeker, KM4ZLD, and Eric Broyles, KJ4KEU. I wanted to make sure you heard this, because y'all two are the winners of the N3FJP software package. That's Alan Meeker. And Eric, you got the ebooks from Dan Romanchuk, KB6NU. But I haven't heard from y'all yet. Please, please, please send me an email with your address to confirm your winnings. Okay? I really need to hear from y'all. Also, while I'm talking here, I want to kind of give y'all a little bit about something that I found. You've heard me before talk about the Ham Radio 360 podcast. Well, I found another really neat, not really podcast. It's actually a live amateur radio show. Really neat thing. I've watched a couple of the episodes. They typically go like an hour, hour and a half, something like that. But they're on like video rather than just audio. Now, these things are... it's the Amateur Radio Roundtable. And you can find the shows, you can find the previous episodes on YouTube, but you can also go to w5kub.com and listen to all the previous episodes as well as get other information. So make sure you check that out. Show Tom Medlin, W5KBU, some interest. Check their Amateur Radio Roundtable out. It's live every Tuesday night, I believe. Actually, when I'm recording this, it is going live. Every Tuesday night at 8 p.m. Central Time. You can watch it online live. You can actually hear it on shortwave radio. I don't have the frequency in front of me, but it's actually on a pretty much worldwide shortwave station that is rebroadcast on. So make sure you check them out. And Alan and Eric, please shoot me those emails. So let's get back to the topic. And again, I apologize for interrupting. Okay, so we're going to talk about the actual grounding part of it now. And this will, in the topic, there's not going to be any more interruptions. Again, I apologize for the last interruption, but I really need to get that in there. So as far as grounding goes, there's a couple things that you need to make sure that you do. Okay. Now, I mentioned before that you only needed a 1/8-foot ground rod. You needed a wire to connect your tower, your radios to it. That's not right. Okay. And the reason being is because that one little bitty wire, while it's a good connector, doesn't have the surface area really that you need in order to make sure and totally protect, or as best as you can, protect your station from lightning. Okay. You need at the very least a 1.5 wide copper strap. And the reason is because it has a bigger surface area and electricity tends to go along the outside of the conductor, no matter what that is. So 1.5 wide minimum copper strap for your grounding purposes. And this will change with how many coaxes you have in. If you have, say, 3 hard lines, and those hard lines are just shy of 1 inch thick, you need a bigger strap, right? You actually need about double the width of your coax on your strap, okay? So the other thing that you need to think about when you're figuring out where you're going to put your ground strap or your ground wire, if that's what you have to use, you want to keep it as short as possible, okay? No matter what the conductor, no matter what the size of the shape, a conductor has inductance that increases with length. So the longer the wire, the bigger the inductance. So the less protection you're going to have, okay? Connecting your single point ground panel to an external ground should be done with the shortest wire possible, okay? You also need to make sure that it's straight, or at least as straight as possible. Straight is a relevant term here. But you need to keep in mind that every turn that your wire or your strap makes, the inductance of the path is increased by a small amount. Now, it's not a great big amount. It's like 0.15 microhenries for a 90-degree turn in less than 1 inch. Also, keep in mind that speeding electric fields don't like change of direction. Okay, the inductance of each bend or turn represents a speed bump, and nobody likes speed bumps. Going through the parking lot somewhere, going over the speed bumps. I hate them. Well, electricity is the same way. It doesn't like speed bumps. This causes a large change in the field over short distance. Okay, if the change is large enough, some of the electrons may not like it, and they may just like to just fly off into wherever they're going. They might just want to go straight instead of going back down or going, continuing to follow your wire. That's not a good thing because that is an arc. Okay, that's not desirable. We've lost control of where this electricity is going. So keep it as straight as possible. Again, keep your wire at least, or your strap at least 1.5 inches wide, because a number 26 copper strap has less inductance than a number 4 wire. Did you catch that? A number 26, which is a 0.0159 inch thick copper strap, has less inductance than a number 4 wire, which is about, I think about 1/4 inch thick, something like that. And not only that, but it's a whole lot cheaper to buy a little bitty strap that's 1.5 inches wide than it is this big old massive wire. And it's a whole lot more flexible as well. But again, you want to keep it straight, so flexible is not really all that much. So, again, another great reason for using copper strap. Okay? Now, the goal is to make the ground path leading away from your single point ground panel more desirable than any other path. In order to achieve this, we need to find the total amount of coax surface coming in to your ground panel from your antennas. The circumference of a single 9913 coaxial cable represents about 1.27 inches. Okay? To make your ground path more appealing to surge energy, you need more than 1.27 inches. If you have a single 1.5 inch wide conductor leaving your panel, you need like a 3 inch or more strap. Okay? If you have a hard line, like I mentioned before, and I actually said 7/8 of an inch, it's actually like 7 inches thick. You need at least 9 inches. Okay? 12 would be better though. But basically what I'm saying here is the total width of your coaxials coming in, your ground strap needs to be wider. Okay? Now, how do we make a good ground system? It's not just with that single 8-foot 1/4 inch ground rod, copper rod. That's not good enough. Okay? If you are just now putting your tower up, don't do like I've done. At one point in time, I had my tower where it was right next to my house, and my house was part of the support system for the tower. That's not a good thing. You really want to keep your tower at least 20 feet or so from your house. And this distance will provide sufficient room for dissipation of the magnetic fields during a lightning strike. Okay? So let's talk about the grounds, the actual ground rods, and the radials that you need to help protect your system. Okay? You want to make sure that your radials go out in 8 different directions away from your house. Okay? So if you have your tower to the north of your house, you want to make sure that the radials go out from a, say, east to west direction. East up to north and back to west. Those are the directions. You don't want to send that electricity towards your house. So that's the first thing you need to do. You also need to make sure that each radial of bare copper wire, preferably a strap, is buried 6 to 18 inches below the grade. So bury the wire. And each one of these radials need to be hooked to a ground rod that is strategically placed. And by that I'm saying, if you have an 8-foot ground rod, your ground rods need to be 16 feet apart. And you probably should have like 3 of them, I think. I never really saw a good example or a good explanation to how many ground rods you need. But in the picture that's on the show notes, it shows 3 or 4 of them. So, but either way, you need to have your spacing of your ground rods twice the length of the ground rod. So if you use a 2-foot ground rod, you need to space them out every 4 foot, but still covering that same distance So if you have, say you have 3 ground rods, then it would be 8, 16, 30, 20, 24 foot long. So if you have 3 of them, and if you only have a 2 foot ground rod, then you need 1 ground rod every 4 foot over that same 24 foot span. Okay. Now, make sure that when you drive the ground rods, you drive them mechanically. Don't dig a hole, put your ground rod in, and backfill around it, because this will not make sure that the ground rod has a reasonable connection to earth. It disturbs the soil too much. There's going to be shifting and stuff, and it's not going to make a good quote-unquote ground. Okay, so take a hammer, take a T-post driver, whatever it takes, and actually physically drive it into the ground like a hammer. Okay. Now, when you're figuring out on your radials, make sure that if the radial comes within 4 feet of a metal object, it must be bonded to that metal object. Okay, and this includes things like a fence post. If it comes within 4 feet of a fence post, you need to bond it to that fence post. Maybe a kid's swing set or a buried fuel tank. Anything metallic. If the radial comes within 4 feet of it, it needs to be bonded to it. So it will help dissipate the energy, I guess. Now, another thing that you can do, a lot of times, at least I would hope, that when you made your tower, when you made your base, you had rebar in it. Okay, you can use that rebar to help subsidize your grounding system. As long as you have at least 4 inches or so above the rebar to the top of the concrete. Okay, so you can attach a wire to each leg of your tower into rebar inside the cement. It's not gonna, the electric thing is not gonna blow up the concrete, so don't have to worry about that. But you need to make sure you can use that to subsidize your grounding system. Okay. Something else that you need to think about when you're doing something like this is most towers are made with a zinc-coated steel or galvanized steel. Connecting a copper wire or strap directly to a tower leg will cause the zinc to erode, allowing the base steel to oxidize or rust. Now, this is not a very good idea if you have a 100-foot tower and the legs are rusting, because it's going to collapse on you. So if you're going to do something like this, you need to have a piece of stainless steel between the zinc and the copper. You can also buy a commercial tower leg clamp that you can use as well. So let's talk a little bit about some specifics. Okay, like I said, in general, doubling the number of radials lowers the impedance of the ground system by 1/2. Actually, I didn't say that before, but in general, doubling the number of radials lowers the impedance of the ground system by 1/2. So if you have twice as many radials, you have half of the impedance. Who would have thunk it, right? Radials don't have to go in a straight line. They can follow the contour of your property or flow around obstacles. Just make sure that you make turns gradually within like a 12-inch or so radius or larger. A perimeter ground that only goes 3/4 of the way or halfway around a house is better than no perimeter ground at all. Although flower beds, walkways, and driveways frequently present insurmountable obstacles, do your best to make most of the way around. The perimeter ground must at least connect to the utility ground. Now, I didn't talk about this before, but basically this is a ground rod that goes from your single point ground around your house, around your shack, or wherever it is that your equipment is at. You should try and make a ground loop, a perimeter loop around it. Okay, and it doesn't have to be all the way. Like I said, it can be 3/4 of the way, halfway, whatever. But you should try at least make it to the utility ground, just for extra protection on the AC side, right? So, like I said before, though, you can use a shorter ground rod. They're better than none at all. Just make sure that you place them closer together spaced at twice their length. So 4 foot one, space them every 8 foot. 2 foot one, space them every 4 foot. Soil doping can improve soil conductivity, but be aware some additives may cause ground and water pollution and can shorten the life of the grounding material. Why you would do this, I don't know, but some people, I guess, can, where possible, install a new tower. Place it at least 25 feet from your house. 30 is even better. By placing a tower at some distance from your house, you minimize the amount of magnetic energy that will couple from it into the wiring of the house. In addition, you take advantage of the induction of the coax line in limiting the surge energy headed towards your equipment. Don't get too carried away with the distance. The added feed line also attenuates your signal. So don't put it 100 feet out because you're going to lose some of your signal, but try to get it at least 20, 25, 30 feet or so. If you're fortunate enough to have multiple towers, each one of them should have their own ground system of radials and ground rods. If the towers are within 100 feet of each other, the radials should be interconnected between the towers, okay? Now, I mentioned earlier that we're going to talk a little bit more about coaxial grounding. Here's where we're going to talk about it. Coaxial grounding not only is the polyphasor inline protector that you have on your single point ground, but also your coax needs to be grounded on your tower. Okay, so if each coax that transverses your tower needs to be properly grounded to the tower, the first point should be at the top of the tower where the coax connects to your antenna. The second point is where the coax leaves your tower to go to your radio equipment. So at least 2 points you should ground your coax on your tower. Okay. If by chance your tower is taller than 150 feet, every 75 feet down the tower as measured from the top. So if you have 150 feet, you need to have one at the top, one in the middle, one at the bottom. Okay? And you need to make sure and weatherize everything and all that good stuff because you're going to ground the shield of it. So you're going to have to cut into it and you need to weatherize it afterwards. Okay? Now, like I said, some places you can't do stuff like this. So you can do like, connect to your water line or connect to a gas, probably not a gas line, but there are other ways that you can ground your system if you can't have something like this. Some type of connection is better than none. So do what you can. But first off, make sure you have that single point ground because that's probably the most important thing of this system. You can use, steel in a building, a standpipe, a metal cold water pipe, metal building skin, the electrical system safety ground on your fuse panel, stuff like that. All that can be used if you can't put a system like this. So that pretty much wraps it up. Please make sure you head over to the show notes of today's episode. There is pictures of all the stuff that we've talked about, as well as some links on some of the pictures that you can go to Amazon and buy them through my affiliate link. So if you have any questions, please feel free to leave a comment in the show notes or on Facebook, and I'll try and answer them to the best of my ability. But make sure you also, if you want to read further into this, make sure you go to the ARRL website. There is a link in the show notes that you can go to and find all of these, plus a whole lot more information that the ARRL has put together. So I hope that y'all enjoyed this segment. It's gone a little bit over. We're already over an hour, and I still have some other segments to go. So let's go ahead and move on to that. All right, so we have quite a few upcoming events, not as much as in the past, but let's go ahead and get started with those. All the times that I'm going to be mentioning are in UTC time or Zulu time, so just make sure you're aware of that. First off, February the 18th from 0000 hours to the 26th at 2400 hours is the Novice Rig Roundup. February 18th at 0000 to 2400 hours on the 19th is the ARRL International DX Contest on CW. February the 18th from 800 hours to 1000 hours is the SARL Youth Day Sprint. The 18th from 1200 hours to 11:59 on the 19th is the Russian PSK WW contest. The 18th from 1900 hours to 2059 is the Feld Hell Sprint. The 20th from 200 to 400 hours is the Run for the Bacon QRP contest. The 22nd from 0 to 200 hours is the SKCC Sprint. On the 23rd, we have the RSGB 80-meter club championship on CW, and that runs from 2000 hours to 2130. On the 24th, from 2200 hours to the 26th at 2200 hours, is the CQ 160-meter contest on single sideband. On the 25th, from 600 hours to 1800 hours, is the REF contest on single sideband. The 25th, from 1300 hours to the 26th at 1300 hours, is the UBA DX contest on CW. The 25th, from 1500 hours to 159 on the 26th, is the South Carolina QSO party. Kale, are you gonna be participating in this? I wish I had my HF radio up. I really do. All these contests and stuff that I talk about, I would love to participate in some of them. Next up, the 25th at 1800 hours to the 26th at 559 is the North American QSO party on RTTY. The 26th from 900 hours to 1100 hours and from 1500 to 1700 hours is the High Speed Club CW contest. On the 26th from 1300 to 1600 hours is the SARL Digital contest. And last but not least, February 26th from 1500 hours to the 27th at 059 hours is the North Carolina QSO party. So got South Carolina on the 25th and North Carolina on the 26th. There you go. One full weekend of QSO partying in 2 neighboring states. All the information was taken from the WA7BNM contest calendar, which you can find a link to in the show notes of today's episode. Let's move on to hamfests. Alright, so hamfest for the next 2 weeks. Starting on the 17th, we have the Arizona Section Convention, the Yuma Hamfest in Yuma, Arizona. On the 18th, we have the Algonquin ARC Ham Radio Flea Market in Marlboro, Massachusetts. The Arkansas Section Convention LCARC Winterfest in Hoxie, Arkansas. The Brooksville Hamfest in Brooksville, Florida. Brownsburg Hamfest in Brownsburg, Indiana. Cabin Fever Reliever Hamfest in St. Joseph, Minnesota. The Highlands County Hamfest in Sebring, Florida. And the Salem Ham Fair in Rick Reel, Oregon. On the 19th, we have the 46th annual Livonia ARC Swap and Shop in Livonia, Michigan. We have the Mansfield Midwinter Hamfest in Mansfield, Ohio, and the Swap Fest in Brighton, Colorado. The following weekend, on the 24th, we have the New Providence Amateur Radio Club annual auction in New Providence, New Jersey. On the 25th, which is a very busy day for Hamfest, we have the 2017 New Mexico Tech Fest in Albuquerque, New Mexico, the 9th Annual Winter RF Fest in Perry, Iowa. We have the Central Dakota Amateur Radio Club Hamfest in Bismarck, North Dakota, the Dalton Hamfest in Dalton Hamfest in Dalton, Georgia. That's a mouthful for me for some reason. The Duggar Amateur Radio Club Hamfest in Duggar, Indiana. HamCon in South Birmingham, Vermont. LaPorte County Amateur Radio Hamfest in LaPorte, Indiana. Orange Hamfest 2017 in Orange, Texas, not too far from me. The Utah VHF Society Swap Meet in Farmington, Utah. West Central Florida Section Technical Conference, the 3rd Annual TechCon in Sarasota, Florida. White Mountain Amateur Radio Club in Chochora, New Hampshire. I'm sure I probably butchered that name. Winter Hamfest in Big Flats, New York, and Winterfest 2017 in Augusta, Maine. On the 26th, we have the Long Island Hamfest and Electronics Fair in Hicksville, New York, And last but not least, the Washfest 2017 in South Park Township, Pennsylvania. All the information in this Hamfest segment, it was taken from the ARR Hamfest calendar. Links to all these, as well as the full calendar itself, you can find in the show notes of today's episode. All right, let's move on to the news. All right, so first thing I want to talk about is something that just really baffles me. Why on earth the ARRL would seek opinion, would even try to have a new entry-level license. It just baffles me. Well, the ARRL seeking opinions concerning possible new entry-level license. I hate it. I hate it. No, we don't need one. Okay, so what this article says is that an entry-level license committee was established by the ARRL Board of Directors and appointed in September of 2016. Why is this the first that I've heard of it? That's just not right. As part of its ongoing work, the committee is gathering members' input and will make recommendations to the board for possible rule change to submit to the FCC. This result could mean changes in the technician license, but it could also be an additional but simpler license with privileges that would give a newcomer a taste for most facets of ham radio, from HF to VHF to UHF. No. Just no. The committee was created an online survey. Please make sure you complete and submit your survey no later than April 7th, 2017. Survey results will be published. Please go to this online survey, take it, and voice your opinion. Is the technician class that hard to pass? No, it's not. It's super easy. You know, we've seen a massive influx of new amateur radio operators, and a lot of them are technicians. And you know, this brings me to another thing that I read not too long ago, kind of a side note, but basically in the same thing. My good buddy Dan, KB6 and you, wrote a blog post a couple weeks ago that deals with this. And there's one of them that is basically his opinion on this news article. But there's another blog post that kind of interested me. And I wanted to see what y'all think about it. See if y'all feel the same way. I mean, he pretty well hit the nail on the head as far as I'm concerned. The question was, it was sent to him in the email. The question was, why is there so many techs? His response, like I said, is pretty well head on a nail. However that saying goes. Okay. His responses was, it's pretty easy to get a technician license. So with a lot of people get them just for the challenge, but never really intend to use the license. I can see that. It is easy to get a technician license. Why the ARRL would want to make it easier or have a new class of license is just beyond me. His second answer, some people get a tech license, but then find out amateur radio isn't what they thought it was going to be and have no reason to upgrade to a general. Okay, I can kind of see that too. Some people get a this is number 3. Some people get a tech license, then can't find an Elmer to help them. They lose interest and give up on ham radio. This, ladies and gentlemen, is our bad. This, as a experienced ham, as a higher class licensee, this is our bad. And I actually had a podcast episode several episodes ago. I don't remember what the number is off the top of my head. I'll have to see if I can look it up real fast. But somebody not finding an Elmer, that is on us. That is on us as older hams. And I just looked it up. The episode number is episode number 35. It's entitled Elmers, Are You Doing Your Part? You can find that at everythinghamradio.com/podcast/35. So if somebody gets a license and can't find an Elmer, shame on them. Shame on those that gave them the test. Shame on the club in the area that they can't get together. And I hate to do that. I hate to put shame on somebody, but you know, that's just the way I feel. And this doing this podcast is my way to be an Elmer. Okay, this is the way that I can teach those newcomers, those technician licensees, or even those that have an extra class that doesn't know some of these topics. Every one of the topics that I've done, every 56 episodes, I have learned something from. So I'm not only teaching myself, but I'm teaching y'all. So this is my way of Elmering. Are you doing your part? Sorry. Okay, I'll get off my soapbox now. Number 4 answer that he gave. Some people get a tech license, buy a HT, and think that all there is to do in amateur radio. They quickly lose interest in amateur radio because talking on the repeaters just isn't all that interesting. And it's sad, but it's true. Some places, their repeaters are just dead silence. And I have my hand raised here because that's the way ours is here locally. 20 years ago when I got into the hobby, there was there was less hams, but there was a whole lot more traffic on the repeaters, on Simplex in the area, on VHF. On VHF and UHF in general, there was more traffic here locally. So shame on me and shame on us in this area for letting that happen. And I know that it happens in other areas as well, because I hear it all the time. There's just no traffic on my local repeater. His number 5 answer. Some people get licenses to participate in local emergency communications or CERT organizations. There is no need for them to get anything more than a technician license. And this is very true. I've given several tests to emergency management personnel, coordinators, different people that basically all they use it for is during an emergency, during a disaster, when their local EOC is activated. Maybe they are the EOC radio person, and when their EOC activates during a storm, they go to it, they talk on the radio, they get off. They have no other need to move on further, because that's the whole reason that they got their license. Same thing with a CERT organization or a search and rescue team, something like that. If they can use a handheld and that's all they use, why would they need to upgrade? So, yeah, there you go. So I totally agree with that statement. Number 6. Since it's so easy to get a tech license, even those that aren't technically inclined get them. Getting a general class license required too much study for them. I can see that too. Some people just don't really like studying. Some people don't really understand maybe or aren't good at studying. And the general class takes more training, more studying to upgrade. On that same note though, Dan has this awesome book, the No Nonsense Study Guide for General Class and Extra Class, that you can get and get your general and extra class. So there you go. That's some way. His number 7 answer. I see this in my daughter all the time. Some people are just lazy. Yeah, that's my daughter through and through. I'm not going to get into that because it has nothing to do with amateur radio, but definitely that part. Some people are just lazy. Fits her to a T. Okay, I'm going to get off my soapbox on this thing here. Let me know what y'all think. Is there any other reason that you can think of why there's so many tech licensees? Leave a comment in the show notes or on Facebook and tell me what you think. All right, one more quick thing, one more news article that I found quite interesting. This really goes for all y'all teachers out there. If there's any teachers that listen to this podcast, listen up, because this is for you. The ARRL announces 2017 Teachers Institute on Wireless Technology. In the past, I've read some interesting articles about this, and it seems like I would really love to do this, but I'm not a teacher, so I have really no reason to do it. But anyways, it reads, the ARRL has announced this 2017 Teachers Institute on Wireless Technology schedule. This summer session will be held in Dayton, Ohio, hosted by the Dayton Amateur Radio Association, or DARA, and the ARRL headquarters in Newington, Connecticut. The deadline to apply is May 1st. Past participants who have completed the introductory TI-1 course may want to consider signing up for the advanced TI-2 session on remote sensing and data gathering. The expenses paid intensive professional development opportunities offer educators training and resources to explore wireless technology in the classroom using amateur radio. Topics covered in the TI-1 Introduction to Wireless Technology includes basic electronics, radio science, microcontroller programming, and basic robotics. Among other activities, participants will learn how to solder and practice building a digital clock. They also learn basic circuit concepts and how to use basic test equipment. Educators in the TI-1 class will also learn about amateur radio, taking part in a hidden transmitter hunt, and see a demonstration on amateur radio satellite communications. Students will build and program their own simple robots. An amateur radio license is not required to take the TI-1 class. Applicants to the Advanced Teacher Institute TI-2 on remote sensing and data gathering must hold an amateur radio license and have completed the TI-1 class. The class will concentrate on analog to digital conversions and data sampling. The participants will receive telemetry from amateur radio satellites and apply it to a math and science topics. TI-2 participants will also construct a marine research buoy equipped with environmental sensors, build a microcontroller to sample the data, configure it for automatic packet reporting system or APRS transmissions, and receive and upload data to a spreadsheet for analysis. Introductory TI-1 ARRL Teachers Institute sessions will take place on July 17th through 21st in Dayton, Ohio, and July 24th through 28th at the ARRL headquarters. One advanced class, the ARRL Teachers Institute class, will be held on July 10th through the 13th at the ARRL headquarters. You can check out the video. There's a link in the show notes, as well as the article on the ARRL. And at the Teachers Institute, there will be more information on the ARRL website. So if you're a teacher and this sounds interesting to you, check it out. It sounds awesome to me. Like I said, I wish I was a teacher sometimes and could go to something like this, but I just have no use for it in a non-teaching environment. So, yeah. Well, that pretty much wraps up this episode. I want to thank you for listening today. And if you like what you heard on this podcast, please share it with your friends. Share this post that you see on Facebook or on Twitter. Share with your friends. Help me spread the word. If you would like to help support this podcast, you can do it in one of several ways. You can become a Patreon and make a per episode contribution through Patreon. You can make a one-time donation through PayPal, or you can simply shop on Amazon using my affiliate link. There is a link in the sidebar that will take you to it. As well as you can go to the support page at everythinghamradio.com/support for information on how to do all these. If you have not done so, please subscribe to my email list. You will receive an email when I publish a new podcast episode. It's super easy. There's a form on the show notes, as well as you can go to everythinghamradio.com/subscribe. Fill out the form, click on the sign me up button. You'll get an email with a link on it that you'll need to click on. Once you've done that, you'll start receiving emails from me. I don't send a whole lot of emails out, just basically the episodes that I release. Every now and then I'll have something else, but not a whole lot. I hate spam as much as anybody does, so I promise I will not sell or rent your email address to anyone. Also, please follow me on Facebook at facebook.com/everythinghamradio. Also have a newly formed group at facebook.com/groups/everythinghamradio. I'm on YouTube at youtube.com/everythinghamradio and on Twitter at K5CLM. So, I guess that's pretty much it. And so, until next time, this is K5CLM signing out. 73, y'all.